Welcome to the exploratory data analysis of the first project. We are going to start by importing our libraries. Import pandas as PD, and let's add cells. After adding cells, we can use pd.read_csv in order to read our data. We are going to be working with supermarket data in this project. Let's check the first 5 entry by df.head, and as we can see, there's store ID, store area, items available, daily customer count, and store sales in our data as features. We can also check by df.columns. We have 896 rows and 5 columns. For getting the maximum index, we used index max, and it's the 649th entry. We're going to use dataframe.ilog for finding that row. We can also use this for index minimum. We need to write one less of that entry to reach the specified column, row. ilog 30 for reaching that index minimum. Now we can drop the user ID column that we are not going to use in any of the machine learning part or analysis. Let's check. Write columns as string, and it worked. Now we can see we don't have store ID anymore. Dataframe.duplicated.sum. For checking if there is any duplicated row in our data, and there is none, as you can see, it returns 0. And also check for NA values, dataframe.isNA.sum, and there is 0 also. Let's check dataframe.info. And dataframe.describe for numerical summaries. There's a large spread in daily customer count. There's of course outliers. We're going to be changing that in the next lesson. Let's take the correlation coefficient values for the store sales and sort them by sort values. We got such poor correlation coefficient values, so I think it's going to be hard to build effective machine learning models, but we are going to try our best to find a good model. Let's import the needed libraries for making our data visual. We are going to start with payplot. It takes a little bit time. As you can see, we plotted the feature correlations and histograms. Here's the pair plot. It's like a heat map in Seaborn, but it's more visual, so it can be preferred. SNS.displot data is equal to data frame that we assigned x is equal to store sales and let's set bins as 50 and color as yellow. Here is the histogram distribution of our store sales. Welcome to the feature engineering of our first project. Let's check df.describe again. Daily customer count spreads 10 to 1560. So we are going to remove outliers from there. Let's firstly set IQR. Let's set upper limit and lower limit. Now lower limit. And we are going to take the entries that we want by df.log. We are going to change the values with NA if they are outlier. If the entry is bigger than the upper limit, we can change it with NA. So in this way, we can delete them after. Let's import numpy for this task. In this way, we are going to delete them easily with drop NA. If the entry is smaller than lower limit, then we are going to change it with NA2. And let's apply drop NA. Let's set our x variables. Store area, items available, and daily customer count. I'm going to use .copy in this one for you to see, but it's not needed. Store sales as our y variable. There was a typo. Let me change it quickly. Okay. Now it worked. we set our x and y variables. Let's import train test split. Splitting our data is really important because if we don't split, we can test our model. So we are going to split. Now here we split our data. And we are going to scale our data. We imported standard scaler from sklearn that preprocessing and scaler is equal to the standard scaler. And scaled x train equals to the scaler dot fit transform x train and scaled x test is equal to the scaler dot fit transform x test. Only scaling the x is enough. Okay. We are going to define a function that will return our regression results. It's a useful way to test many models because writing one by one can be hard, so by this way writing one time is enough. It's normally in the machine learning section, but we are going to apply this in this video. We done feature engineering with scaling our data. Let's define model results and give predictions inside. We wanted to print mean absolute error on model S. That format, mean absolute error, y-test, and the predictions that we pass inside. And let's do the same for the root mean squared error. That format, numpy dot square root mean squared error, and y-test and predictions. Welcome to the machine learning part of our first project. Let's import linear model, linear regression from linear model. LR equals to the linear regression. LR.fit scaled X train and Y train. Predictions LR is equal to the LR.predict scaled X test And let's get the model results. Our models are going to be bad resulting, but we are going to try to find the best one. We are getting bad results because we have poor correlation coefficient values. Let's import support vector regression fit, scaled X train, Y train. Numbers are large, but the numbers in our data is also large. So these results are not that bad, but they are not perfect. Our support vector regression performed better than the linear regression. Let's import grid search, which is for hyperparameter tuning. And let's select the best hyperparameters for the support vector regression. Parameters grid SVR equals to the C 0.001, 0.01, 0.5, and kernel, poly, and RBF. Gamma, scale and auto, and setting the degree 2, 3, 4, 5, 6. Now 5 is enough. We don't want it to take a lot of time. It's going to try every model with each combinations and give the best results. It's the main focus of the grid search. We set our grid search and let's fit it. Grid SVR scaled X train, Y train. Let's fix the typo, as is going to be lowercase. And it fits. Now we can check the best parameters. Best parameter for the model is that format grid SVR dot best params. C is 0.5, degree is 5, gamma is auto, and kernel is poly for the best parameters. Now we can predict our X-test values and see the model performance. It got better with hyperparameter tuning. RFR.fit scaled X-train and Y-train. After fitting the random forest regressor, let's take the predictions. RFR.predict scaled X-test model results. Predictions, we passed inside and we got our results. Now let's use grid search for hyperparameter tuning. We are going to set parameters, bootstrap true or false, max depth 5, 10, 15. Max features auto log 2, number of estimators 2, 3, 4, 5, 6. Let's write normal because we don't want it to take a lot of time testing all of that. Let's fit a random forest regressor. A regressor as it's fit. Let's print out the best parameters. Sorry, my mistake. Let's fix it quickly. Our best parameters for model is bootstrap is equal to true, max depth is equal to 5, maximum features are auto, and number of estimators are 3. Let's define our predictions. Predictions grid search RFR is equal to the grid RFR dot predict scaled X test. And here's our result from machine learning model.